Hi, and welcome to yet another episode of CodePub. This is our first MetaDev episode, and as we announced in our intro episode that we did last time, we will be talking some very interesting concepts that have sort of an intersectional thing going on. So today we are going to talk about abstractions. So Boro, what are abstractions?
Before we start with that first episode, so we had the pilot run. Are we starting from zero indices?
I mean, we could consider the intro like a zero index. So, this is our, CodePub 01 or CodePub MetaDev 01 or whatever. We haven't decided on a count. So, bear with us, I guess.
Yes, because I remember, I know only Pascal, the programming language that started with indices with 1, and I think most other languages start with 0 indices, but
I would say that there are languages that start with 0 and there are languages that are wrong. So
and this is a good
opinion.
Right, this is a good discussion because I think it will lead us to the topic of this session about abstractions.
Yep.
So why are some abstractions like that, and why are some other abstractions like taking a different route? So what are abstractions? It's a very tricky question. I would start with that. And in my opinion, I view abstractions as the process to remove the details of an object. I think I could generalize it up to that point. But of course, as we go through this episode, we will dissect it more and more. But I think it's a good definition to start building upon. And I would ask you the same. What are abstractions in your mind?
Well, primarily I would say barring any academic definitions, I would say that it's a tool that allows us to think better about a group of things. Basically form an idea that would allow us to communicate a group of things better.
I definitely agree with that. I definitely see abstractions as a way, as a bridge to communicate between two or more developers. And it's really important how and where we choose our abstractions and in which context. So we can never say something like abstraction X, let's say MapReduce or singleton or whatever, is a good abstraction. We can never say that because it very much depends on the context, depends on the people we work with, and of course on the project that we work with.
So would you maybe say that abstractions are applicable to groups of people and towards the target we're trying to communicate to? And sometimes certain abstractions may not work in certain contexts.
Exactly my point. I would also say, to build on top of that, I think we can set some definitions clear before we start diving deeper into the topic. I think Donald Knuth said something along the lines of abstractions are mostly for humans a tool for humans and not so much a tool for the computer, because the computer does not know, if you go to the lowest level, it does not know anything beyond ones and zeros. So in that sense, if we agree with the definition that abstractions are mostly a psychological tool for people to communicate with, then I would say there is, I would agree with the definition, and I would say that there is a lot we can build on top of that.
Yeah, absolutely. So in a sense, the computer or the processor at the lowest level doesn't really care whether you're writing classes, for example. A class is something that we define so that we have a better understanding of our idea of what we're trying to convey to the processor and what ultimately ends up on the user's screen or whatever, on the machine's process or whatever we're trying to solve at that given time.
Exactly. And I would like to start with before we go into the computer world, I think an interesting question is, you can basically ask any person about this, is what is a chair? I think this is a very interesting question because it can lead us slowly into the topic of abstractions and what does it mean to be a chair. Okay, so we have a lot of different kinds of chairs in the world. Some of them have 4 sticks, some of them have 3. But the main idea is, when you see that, and you can sit on that, it's a chair for you.
Yeah.
So it does not, when we communicate with other people, we don't say, I want to sit on that black chair, or I want to sit on that white chair.
Yeah, I see.
You just say, I want to sit on a chair. So abstractions are deeply ingrained into our minds, and before anything, before programming or any other areas or domains we dive into, abstractions are a very natural way to sort of communicate, I would say, because it's not, in my opinion, I would also like to hear your opinion about this. It's not always, let's say, sometimes there is information that you don't want to communicate, right?
Yeah.
Because it does not matter if the chair is black or white. What it matters is that it is a chair, and in this context, the person just wants to sit somewhere on a chair. So it's very unlikely that you will go to your friends and say something like, I want to sit on a black chair or on a white chair.
I mean, if you're very much into black chairs, I suppose you could ask that, but...
Yes, but now we are talking about a different level of abstraction.
Yeah, of course.
So a black chair, if we start at this level of abstraction, having this conversation, you and I, it's a different level of abstraction in the sense that now the focus or the emphasis is on a black chair.
Yeah.
But in general, in like everyday communication situations, you very unlikely would say something like, I want a black chair.
Yeah.
Unless you're, so yeah, it could be valid. Like, for example, let's say you go to some shop and you want to pick a chair, and then you make decisions based on your color preferences, on the chair height and things like that. So definitely, in this context, the abstraction is more at the level of we don't want so much to remove the details of the object. We actually want to focus on the details.
Right, yeah.
And I would say there are still abstractions here, but we are focusing on a different level of abstraction. And so if we see abstractions as sort of a ladder that you can climb up and down infinitely, and if we agree to this, then you and I, firsthand, we have to agree, okay, Darko, right now you and I are on this MetaDev podcast, and what is the level of abstraction that you and I communicate? Do we communicate this for viewers? Do we communicate this for ourselves? Do we communicate this for our children or whatever it is? So in any case, if we agree that abstractions first are only for humans and are a tool for communication, then the next point in abstractions is what is the abstraction level that you and I have agreed upon so that we can transmit information?
That's an interesting question. Like, in many ways, it could be, just a faulty way of, let's say, trying to transmit something, because like the default idea of what I have in mind of what a chair is and what you have like as a default chair might be completely different. But we could agree maybe on a set of properties that, this is an object I can sit on. So like, let's throw a wrench in that for a second. What if I try to sit on this table here, and like, would that be considered a chair in that sense or not?
By the way, this is a really good topic. We are sort of diving into more. So Wittgenstein's philosophy, for example, is has been in most of his focus in his work. He has been focusing on what kind of meaning the words have and whether we can fully transmit some piece of information to another human being.
Yeah.
I would agree with you that this is impossible.
Impossible with accuracy, but impossible on like a workable level.
Exactly.
I would say, yeah.
Yeah, I that's what I meant. Yeah, so we can probably, and I'll just throw this number right there, probably like 70% we can agree or we can understand each other, but I will never have the clear idea of what Darko means of a chair and of what Boro means as a chair. So, and definitely, if you and I work in the context, in the abstraction level of now tables can also be used to be sat on, then this is understandable. There might be a context. Let's say you and I are in, nature, drinking beer, making some barbecue, whatever, and we don't have any chairs, so we just use the table to sit, of course.
Yeah, you'll improvise. It will work.
Yeah, but I would say, to your point, abstractions really provide us means to focus on the properties of the object. So if we agree on the abstraction level that right now we are focusing on sitting or being able to sit somewhere, then of course, you can sit on your computer, you can sit on a chair, you can sit on a table.
Yeah.
But it all depends on the context, and it depends on what is it that we want to communicate firsthand.
Yeah, absolutely. I was coming from a different perspective when you mentioned Wittgenstein. I was sort of like, come on, man, that is like a bit too much, but never mind. I had the idea of like leaky abstractions, and I had the idea of like, breakable inheritance chains when it comes to classes and stuff like that, but we'll get into that a bit later. But it's an interesting take as well, like that level of abstractions and like the problem that no two people think in the same way, and as a result of that, abstract in the same way.
Right. And I mean, yeah, and we will get into the programming details about this, but just my point is that it's very natural to think about abstraction. And I would also like to mention one quote from Paul Graham, which said something along the lines of, abstractions are a good way to relearn something, and a bad way to learn something. And I want to like just dissect that a little bit, because
Sure.
if since you and I both agreed that abstraction is the process of removing details of an object, then of course for a beginner this is not helpful. This is not useful. If you tell, let's say you there is this person that just wants to learn how to build chairs, and then the only thing you tell them is a chair is something to be sat on.
Mm-hmm.
And of course, this person will never learn the process of building a chair, because we are already into the abstract. And at this point, for beginners, let's say, abstractions are not so useful. So there is the other part, the opposite part of abstractions, which is being more concrete. Okay, so, and we can start with something like, okay, so now if you want to build this chair, you need to have like this, sort of piece of wood that will be holding the base of the chair, and you need to build 4 of those.
Mm-hmm.
So you slowly start to build the concrete image in his mind or in her mind. But at the same time, this concrete example is so limiting, because in this person's mind, a chair has 4 sticks always. And the reason why it's limiting is because it limits the creativity, it limits the imagination. And I think abstractions are most useful when you already have some experience in the domain, knowledge, and then you want to go beyond the basic experience.
Okay. I have a sort of a counterpoint informed by a couple of very smart people that did the Learning How to Learn course on Coursera, and a bunch of other ones that propose analogies and metaphors as very good learning tools for beginners when you're trying to, understand something that's of very complex nature, when you're trying to get into a very complex topic. Analogies and metaphors are abstractions in a sense.
I would definitely agree with that. And by the way, what I just shared, I think it's more of a personal bias.
Yeah. I was going there exactly.
Yeah. So in my experience, in order to understand an abstraction, I have a need to understand the concrete. So, and I've seen other people like this, okay, you're trying to explain some concept to me, but give me the example first. I want
exactly.
the concrete part. Some people can also think in terms of abstractions, but I would say the risk is there. In every abstraction, you have sort of like an information loss. So some part is removed, and then this information is gone forever. So as long as the person who is used to keep thinking in abstractions, as long as this person has the habit to think about the concrete parts and how of an abstraction they can derive specific concrete instances, then I would say this is healthy. So in this case, I would agree with this course. But in general, beginners, this is my experience as well, and it goes back with how I teach my children mathematics. So for example, when they have to study for a test or whatever, is recently I had to teach my daughter the concept of a function, like a mathematical function. It's very basic. It doesn't go very too high level, but The way I explained it to her was, okay, think that you have this set of persons, so Boro, Darko, etc.,
Right.
and you can map these persons to some kind of object. So what is this object? It could be something like, how old are they?
Mm-hmm.
So a function, what is the age of person X? For Boro, it would say number N. For Darko, it would say number K. And this is one example. So it all starts with concrete examples. And then once I taught my daughter the concept of functions and showed some examples, now she will be able to generalize more. Okay, but so it's for ages, but can I also use it for, for something like, what does this person like? So
yeah, so once you develop the basis of an idea, you're able to sort of like develop it further by making some assumptions and like widening the idea of what a function is ultimately.
exactly, yes. And I think this goes back into human history as well. So if we start like diving into the world of mathematics, for example, what is counting? So
Yeah.
I have watched a couple of documentaries about this, and my interpretations of the historical facts may be inaccurate, but in my mind, it came as a need. So we have a number of sticks,
Mhm.
let's say 3 sticks, and then you just count them. The way you count them is you just like see, okay, 1, 2, 3 sticks.
Yeah.
But 1, 2, and 3 are already abstract objects because there is no 3 or 2 or 1. There is just stick, stick, stick.
The idea of it. Not
Right.
exactly like there is no like concrete thing that you would say is a one, deterministic.
Exactly. So numbers are a huge abstraction built on top of this idea that, okay, I see 3 sticks, stick, 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 or SSS, we can say it like that. And now I need to figure out a way, how can I represent them? So when I talk to Darko or when I talk to another person, look, Darko, there are 3 sticks here, or there are 2 beers on this table that you and I are drinking right now. So what does 3 and 2 mean in this case, going back to Wittgenstein, defining the meaning of words? I think abstraction plays a huge role here. And even, it's very natural for us to abstract things, but even going back to history, how it all started, we can now ask the next question, which is, how was the operation plus implemented? So we have 3 sticks, right? SSS. And now Darko gives another stick to this group of sticks. Now there are SSSS. So we have 4 sticks, but they used to be 3. Now there are 4. So now we have some sort of operation that happened here, which is the plus of numbers. 3 plus 1 is 4. Everybody knows that. But what is interesting is how we came to this operation in the first place. What was the need for?
Yeah, how did we come to the idea that there was something in between sort of as a glue that caused a 4 to happen?
Right. And so this is how numbers were built. And before we had numbers 1, 2, 3, 4, we only had one number, which is S or SS or SSS. And it's inconvenient to write 100 S's, but it's very convenient to write 100. So this is a level of abstraction that is quite interesting in my opinion, which is how we, in the history of humanity, how we found a way to share the same, more or less the same, I would not say exactly the same, but more or less the same amount of information with so little symbols. And this is, I think this is the beauty of
compression of ideas, in a sense, like the efficiency of trying to communicate something over to a group or whatever. So we maybe have a certain, let's call it a 70% overlap in an agreement about what a certain thing means.
Right.
And by falling back on that abstraction, we are able to communicate efficiently.
Exactly. And exactly that. And, I think able to communicate efficiently, this is interesting because I think most of the stuff that we are doing on a daily basis is revolving around optimization.
Yeah,
so we are optimizing. I had to get to this room where you and I will do this recording of the podcast, and I had to manage my time. I had to plan my time. I had to optimize to be right here on time and things like that. So throughout human history, we always optimizing.
We had to have, an agreement of the idea of time first.
Right,
so, yeah.
Right. We can go there.
That's an example.
We can go there for sure. Time is an abstraction.
Yeah.
I would agree with that. But it's so now the next question is, we discussed that abstractions are so ingrained into our human nature, even in the past, and now we probably became more aware about them. But now comes the next question, which is also, I think, interesting. Why are abstractions useful in the first sense? Why do we need them?
Primarily as communication tools. I mean, in my opinion, at least. Like, that was the need that caused them to happen in the first place. As we've established, we already established, like, we have a certain idea and it's easier to, instead of writing a bunch of S's, you could write the number 100. And that already, makes for a more efficient way of communicating a certain idea.
And I would agree. I would say communication is a huge part of that. But I think there is another interesting part, not as important as communication, though I would still say it is important, and it goes back to generalization.
All right.
So like we mentioned in the first part of the episode, speaking about the concrete is good for new people coming to the field to spread their domain knowledge, but concrete is also limiting. So it limits the imagination.
It is.
So if I say any kind of beer has to have the yellow color, now this is actually a huge constraint, and I will never I will never have the chance to try out another beer because that's just not a beer. I mean, wine is red.
Yeah.
So I think this generalization is quite interesting. And we can go back to numbers, for example. So going back to the plus operation, we had 3 sticks. We joined another stick, and now we have 4 sticks. So we are able to count now, and we have properly defined what it means to combine multiple sticks into one. So we have like 2 sets of sticks and we combine them. But now we can stretch this generalization and go beyond numbers. So let's say concatenating lists, for example. If you take the operation plus on numbers and you abstract it highly enough, you can derive all sort of different operations based on that. One operation is string concatenation, and I would say string concatenation and plus on numbers have like have a lot of things that have in common. So for example, first they are associative. What this means is 1 plus 2, and then if you plus 3 on that, it will be always the same with 1 plus 2 plus 3. So if you put the parentheses there. And this generalization, taken highly enough, is the same for lists. So if you concatenate the list of 1, 2 with the list of 3, is the same if you concatenate the list 1 with 2 and 3. So now we are sort of talking at a different abstraction level where we say, okay, well, plus on numbers and list concatenation do have this interesting intersecting property, which is associative. And associative is just another abstraction that we as humans came to agree upon what does it mean for an object to be associative. But I think abstractions are useful beyond what you said about as a communication tool. I think they are useful into giving us more insights into what a chair is, what it could be, or of course what it was in the past. So this is how the abstraction came to be, but also what a chair could be. So all we know about chairs is that they can be sat on, but you can go infinitely, in this process of let's say you're trying to design a new chair, which is like the best chair in the world. So
what makes it the best chair?
What makes it the best chair? Exactly. But it's still a chair because we agreed upon this abstraction. And now if you go outside of the concrete world and go into the abstract world where a chair is only something to be sat on, then your possibilities are endless. I could sit on this pillow, for example, and, in some cultures, like I think in the mostly Eastern cultures, they do sit on the floor and on pillows. So could treat that as a chair. But maybe that's sort of a leaky abstraction.
I mean, it serves the same purpose, but at some point you come to the problem of like when you have like a bunch of classes in Java, a bunch of inheritance and stuff, and you try to insert another property in something that you're already calling a chair, and things start to break down essentially. So yeah, it runs into a problem at which, like, yes, both objects are, serve the same purpose. Sitting down, relaxing, whatever, but they are not of the same nature. They
Exactly.
cover the same idea, but they just aren't the same.
Right. And we can stretch the definition infinitely.
For sure.
Like, what does it mean? What does a chair mean for the end user, and what does a chair mean for the actual chair maker? Or let's say you and I, we go to our dentist every now and then, and we are just shifting the levels of abstractions here. So I don't care about the dentistry internal details. What is dentistry? I don't care about it. I just have it abstracted so much that I can just pay for that and get
you care about the utility of the thing. You don't care about the nature of the thing, essentially. Exactly. So, I get it. I wanted to sort of ask something that a couple of questions back, a couple of discussions back, whatever. How would you, based on the idea that, certain metaphors and stuff are abstractions of sorts, how would you describe a monad? So, like, there in general, I don't want to, put you on the spot. And I know it's a horrible thing to explain. I'm not going to do that. But in general, there are two ways that people go to. It's either the burrito analogy, which is horrible, or there's like this academic abstraction. It's part of category theory. It does blah, 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 and all of that. So, which, when we talked about teaching tools and how you're trying to transfer an idea, which one do you feel is better in general?
This is a really good question. Thank you for asking it. And I think it's a really good topic to dive into. And my answer would be both. The reason why both is...
Spoken like a true senior engineer. It depends.
Or it depends, right? But, we sort of agreed in the beginning of this episode that abstraction is a means of communication.
Yeah, of course.
And so if you have a programmer, and we have like very different profiles of programmers today, right? We have so many programmers, and so some of them are more acquainted with the language of mathematics. Some of them are more acquainted with thinking in terms of boxes or burritos or whatever. And I would say this is a very good question because, at the same time, it also asks the question of how can two people understand each other?
Exactly.
So if you were to combine an academic person and a programmer, sort of an engineer, and it's very likely that these two people will have the difficulty of understanding with each other, because the academic person will go, well, a monad is just a bind that holds these properties. It's just a monoid in the space of endofunctors. And then, the programmer or the engineer would say something like, well, it's just a burrito. And then, they would disagree infinitely.
Yeah.
But I think it's very important to include in this conversation the agreement of like what sort of disagreement that you and I made in the beginning of this episode. What are abstractions and what level do we speak at? So if these two persons never define the level of abstraction they speak at, they will never make any progress.
True.
Because a monad is both a burrito and an endofunctor.
Depends on who you ask, I suppose.
Right. And it's also a box. And some analogies do, like the box analogy, it for sure helps with understanding. But it helps up until a certain point, sort of, it's concrete. So it definitely helps the beginning of starting to understand it. But as you go to like more abstract definitions like semigroup or a monad or a monoid, and you try to define those, return bind to somebody who starts diving into the field, you will not make progress if, let's say, your intention is to not sound smart but to actually transfer information.
You're trying, we're assuming that you're trying to explain this to somebody, you're not trying to sound like a smartass or something
right.
like that.
Yeah. And so, I don't know, if I were speaking to a JavaScript engineer, I would say, well, do you have experience with promises? And if their answer was positive, I would say, well, a specific instance of monad is basically a promise where you can just like, you sort of, you have this chain. You have this concept of chaining where you have one operation and another operation, you can chain those together. Or if it was a .NET programmer, well, do you have experience with Link, for example, the ORM?
Yeah, that's a good example.
And Link also has like this concept of chaining, right? So it's monads, in my opinion, are all about chaining. But firsthand, I don't want to sound smart, but actually I want to transfer information. So
Yep.
I would try to understand this person. What is it that they want and where do they want to go? And at the same time define the abstraction level like you and I did in this in the beginning of the episode. And I think this is important for us to be able to understand each other, because if my sole purpose is to sound smart, I can just throw a bunch of mumbo jumbo mathematics right now and that's it.
Yeah, and you already like win at that game, and that's like sort of not the point anyway. So
I would disagree that winning a game is misunderstanding with others, but it could be. Some people could.
If the game is sounding like a smartass,
right, in this game they definitely won because they just like throw a bunch of mambo jumbo concepts which have no. There is no means of grounds to build upon, and you cannot have any further discussions based on this game. So this is one of the games that I really try to avoid, and I don't care about sounding smart or stupid. I just care about transferring amount of information with you and with other people, and also at the same time receiving the information. But at the same time we have to determine the abstraction level, and I think in my opinion this is the best way to both learn and relearn something.
Do you think that maybe like using abstractions efficiently requires you to adapt to the person or the group you're speaking to?
I definitely agree with that. This is actually one of the, we can maybe start diving into the abstractions in programming right now, but we briefly mentioned that singleton or multitone or strategy pattern, what is a good abstraction basically. And I would say there is no good abstraction. I mean, in the sense of, first you have to keep in mind what sort of company you work for and what is the company culture. Is it a culture where most people speak the language of functional programming, or most people speak the language of object-oriented programming, or a bunch of JavaScript engineers who have a specific place in their heart about Lisp? So it's
That's me, ladies and gentlemen.
Yes. So, and by the way, Lisp is my favorite language as well.
The best language ever. Like you can't argue with that. It's just facts, man.
Yeah, Lisp. I would say JavaScript is a Lisp, and Lisp is so interesting because it has like very small amount of basic fundamental concepts that you can build upon.
Yeah.
So it's like it allows you to build abstractions with very basic tools. But I digress a bit. So to the original point, I would say first identify what is the culture and the people you work with. If these people are a bunch of Haskellers who want like crazy math, language, and they speak in terms of monads and monoids, and if you want to succeed in this culture,
they are obsessed with purity. So
right,
there's that
side effects and all of those bits, like higher order function citizens, whatever. So if you want to succeed in this kind of culture, you have to understand those concepts.
Yeah.
Because you will not be able to speak a different language or understand with them by speaking a different language. So if you try to join a group of 10, and this group of 10 already has a specific set of communication rules, okay, we speak at the level of mathematical algebraic structures like monoid, a semigroup, or group, or groupoid, or whatever. If you don't have a good understanding of those structures, you will not have made a lot of progress in communicating ideas with these people. And but this goes vice versa. You can also state something like, this level of communication that these people are habituated into is limiting, because all they think about is mathematical structures and they don't go beyond that. So the box analogy, for example, can be useful because it can give you other creative ideas. So I would definitely say that depending on which level of abstraction you talk is very important, and it's on the engineer or the programmer to agree whether they want to discuss in this level of abstraction, agree with the company or the engineering culture in this company. And if we have like this as sort of solid base, we can build on top of it. So if we assume this, and then now, we can say like, okay, is this a company that prefers Laravel, or is it a company that prefers React?
Mm-hmm.
So if it's React, there are certain ways you can approach like building a React application. So you have like props, you have like FX, you use those, and everybody will agree in this team with you that, okay, we should use FX here, or drill props or whatever it is. And on the other hand, if you have sort of like the Haskell kind of environment, then you can sort of say something like, well, let's think of type classes, let's think of algebraic structures, let's think in terms of DSLs, domain specific languages. And this will it's all about agreeing, okay, about what are the communication rules.
Mm-hmm.
But there is an interesting twist, I would say, or a synthesis where it's happening right now, and I really love that.
All right.
Where some React programmers, I would not say all of them,
okay,
or some Haskellers, they try to steal from other worlds.
Yeah.
So like I cannot think of a concrete example right now, or maybe I can. I know PHP, for example, has very recently introduced the concept of lambdas.
Mm-hmm.
And lambdas have been in Lisp in the 50s or the 60s. So
yeah, they aren't a new idea. They've been around for a while.
Right. It's like 70 or 80 years old idea, right? But if you think of like the average PHP programmer, it's a person who builds websites.
Yeah, exactly.
And as they grow, they start understanding the concept beyond the website, which is a web application. And then, they go beyond that. They start building classes, they start building abstractions, and then they eventually get to lambdas. And by the way, this is not to say that Lisp people were so smart in the 50s that they knew lambdas was the answer, although there might be some truth into that.
And the drugs were better, apparently. So
yeah. But what I really love about the whole idea of different abstraction ladders and people misunderstanding each other is, if I misunderstand Darko, or if I misunderstand person X, in some cases, this does not hold for every person in the world, but some of those persons will say something like, wait, I don't understand this.
Mm-hmm.
I'm curious enough and I want to understand it. And this is where I think the most interesting of the synthesis happen, where you get weird things like supporting lambdas in PHP, or partial function application in Python,
mm-hmm.
or functions as first-class citizens in JavaScript. So I really love this. I adore this idea of sort of the synthetic combination of these two, the academic world and the engineering world, where they just like they used to be so much in a clash with each other, but now
mm-hmm.
they're just trying to understand more each other, and they are just like stealing concepts from one another.
Yeah, it used to be weird that languages were more of a, where we're trying to live into our own ghettos and not, try to see what's outside of our world.
Right.
Maybe still import an idea or whatever. And it's becoming more the norm. Like getting exposed to newer ideas will probably allow you to create better abstractions, to either communicate with, build with, or whatever. So yeah, like exposing yourself to newer and unknown domains maybe allows you to communicate more efficiently by creating more efficient abstractions.
I definitely agree with that. And I did a lot of philosophy reading lately. And actually my biggest takeaway for that is philosophy is not about, trying to solve some particular problem.
Mm-hmm.
Philosophy is just about bringing more scopes into your toolbox to understand different perspectives. So, I can view this conversation as a scope in the scope of Wittgenstein. So if we decided to do that, we will just like get so stuck into the definitions of words. What is what, or what is this, or things like that.
That's not exactly practical.
Yeah. I would still say it's a useful perspective.
It is, but it's not practical.
It is not practical. But then, you can sort of go like in another route and go like, Socrates, which is question everything. But I would agree that also this is not practical. But what philosophy is most about is about just like having this broad set of diverse scope,
mm-hmm.
where you can view the world through a particular scope. And I would definitely agree with you what you just stated in the terms of programming.
Mm-hmm.
Learn a new different programming language, learn a new paradigm. It's all about increasing your scope and seeing how. So let's say you learn Haskell, you already knew Haskell, but let's say some person decides to learn Haskell and they they see this concept of domain-specific languages.
Yeah,
And
yeah.
now they can get the idea
That's a
of,
good one.
oh, now I can try to build this in JavaScript if they were a JavaScript programmer, or if they were a Bash programmer, I can build DSLs in Bash, and
Exactly,
it gives
yes.
new ideas. So it's definitely useful.
No, it's a slippery slope though. It's one step next to trying to build an interpreter, and that's like, even though it's an interesting workout, I wouldn't recommend you do that unless you're really like into that sort of thing.
Yeah, but at the same time, going back to the Paul Graham quote, I would still agree that abstractions are a good way to learn something new, and a bad way to learn something, or actually I said it wrong. Abstractions are a good way to relearn something, so from a different perspective, but a bad way to learn something. So if you really want to understand how interpreters work, you just better get down there and do the dirty job. Build an interpreter.
Yeah, exactly.
That's the best way. Because if you just like read all of these abstractions, well, an interpreter is really just like a DSL that has an evaluation function or whatever. Not much progress will be made. So I would definitely say use the concrete to learn things. And then once you have, or this is my personal experience, once you have a good grasp of the concrete, go abstract and start, go creative, go wild.
Right. Yeah. Okay. One thing I wanted to ask, like a couple of discussions ago, but it's still sticking with me. How helpful are abstractions in your day-to-day work? Like, as a DevX professional, you probably have to adapt the type of abstractions you're using based on the level of the person you're trying to maybe mentor or interview or do a workshop for. How does that help? How do abstractions work there?
Yeah, we can. As to not keep this discussion too abstract, we can stick to a particular topic. I can take as an example the security workshop.
Yeah, that's a good example.
We are running a security workshop, some context, in Automatic recently with more than 50 teams. And it's a workshop where it's very practical and hands-on. So there are a set of exercises that we ask engineers to go through, and we expect them to finish in a particular time, and then we expect also at the same time that they learn something by this. So now to get to the question, what am I abstracting there, or what am I trying to abstract? First, who will be running these workshops? We have so many teams at Automatic. So in the beginning, it was mostly me doing all of the workshops and trying to get a feel. When you start a project, you are sort of trying to get a sense. You do some simulations and calculations in your head, but you actually have to walk the path to understand most of the stuff. And then, so in the beginning, to get sort of to the concrete level, I ran a couple of these workshops, and figuring out the way I ran them, I thought, okay, maybe so I was a facilitator as well, and maybe I can abstract the concept of facilitators. So why is it only me that's running these?
Yeah, that's a good idea. And maybe like the people that lead the teams would be better facilitators. They know their people.
Right. Or maybe some, engineer that's like gone heavily deep into the workshop, and you see this spark in them that, this is something they want to do. But in any case, it started with, first, I cannot do this all by myself. I need some help. And now I'm also abstracting some of the bits. So I'm not doing all of the facilitations. I still ran a couple of facilitations, but other people started doing these facilitations as well. So one can say that I did an abstraction there, in the sense that I was solving some particular problem with some specific tool, but I decided to construct a new tool, which is other. I don't want to say I constructed other people, but I constructed a new tool which allowed me to run the workshop more efficiently.
Right.
And introducing more and more people is quite interesting, because you get like all of these new perspectives, new ideas. Every person is different. Some of them want to focus more on the code. Some of them want to focus more on the facilitation part, or making sure that the workshop is completed in specific periods. And you have all of these ideas and concepts and feedbacks. So I would say I enjoyed abstracting this, because if it were only me doing all of the facilitations, then nothing would change, or maybe things would change like very slowly. So this abstraction was a huge win in that it gave me a sense of more and new different perspectives. And
So, in many
mhm,
senses, we're circling back to the same idea that, exposing yourself to multiple, maybe unknown ideas, experiences, and perspectives ultimately allows you to build better abstractions and use
definitely,
those abstractions in a better sense.
yes, I would definitely agree with that.
Cool, interesting. Like the reason I asked this initially is that I find myself adapting my abstractions often depending on the person I'm talking to. So for example, if I'm talking to someone more junior, I can't just, start talking function composition with them. No, have to start on a lower level, and then you have to like sort of probe and understand where they are, and then start using abstractions that would actually work for them. And I'm talking here about mentoring work. What's your experience with that?
I have the same experience like you described. First, we have like almost 1,000 engineers at Automatic, and I've done a lot of mentoring sessions. And um, I don't want to just to emphasize that again. I don't want to sound smart, but I just really want to be able to understand with this
Mm-hmm.
person. So the first step is figure out the level of abstraction you and I will talk about. Are Do we know about the concept of function composition, or do we know of the concept of REST API?
Yeah.
Or do we know the concept of abstract classes or classes that inherit? And if we do, then what is your understanding of them? This is another interesting topic,
Yeah,
right?
I mean, certainly some abstractions, as we established already, that some abstractions might not be exactly the same in two people's heads.
Exactly.
Essentially, like an abstract class understanding of person A and the same thing with person B. So they might be able to understand each other to functioning level, but they might not have the exact same idea in their heads.
Exactly. And it all goes back to being able to understand each other and what is your definition of abstract class and what is my definition of abstract class. And this brings the bridges closer because once you are able to establish the connection between these two bridges, now information can freely flow between those two bridges. And to go a bit more concrete, so let's say I'm talking to person X who we decided, okay, I know what function composition is, and I agree with you. You and I have the same view of what function composition is. And now, what can we do with this? What
Mm-hmm.
can we do with function composition, and how can we use it as an abstraction? So at this point, it comes. It is a matter of me having some more experience and sharing this experience with the person.
Yeah.
But like mentorship, like any mentorship session, it's basically a two-way street. So you learn from each other all the time. There is no mentor-mentee or mentee-mentor. I see them as mentor-mentor always.
I mean, yeah, you always learn something whenever you're trying to teach somebody something. So, sure, that stands.
Right. And so, mentorship, first, it's really important for the mentorship sessions to be beneficial for both parties. So if the person and we both agree, okay, this is function composition, this is how I understand it, all of my experience is already known to this person and vice versa, then there is nothing else to extract in the sense of speaking about function compositions. So if we don't find another topic to discuss, then we can say the mentorship is successfully finished or completed.
Yeah, like we're done here. Like,
Yeah.
that's it.
But if it's a matter of fact where this person maybe has more experience from me in one regard and I have more experience in another regard, then we just keep exchanging ideas until we reach this sort of mutual understanding, and there is no new knowledge is not transferred anymore.
Yeah.
And then it may still in those cases I don't want to say that this is the golden rule to stop mentoring, because pair programming is also part of mentoring. And in my experience, no matter how experienced anyone is, pair programming is a very good tool because it allows us to, when you are working on a specific task, you are sort of having this tunnel vision.
Mm-hmm.
And pair programming allows you to have another person who is like viewing you from a third perspective and say something. Hey, you forgot about this, or you forgot about that. Oh, right, I was so deep into this. This is very helpful, So
Yeah, but pair programming like hits different. It has this like multimodal, multi whatever thing that you get to see more things about a person and how
Right.
they're trying to express themselves, not just the coding itself. No, thinking and how they're trying to, set things up, how they're trying to, again, abstract things from the get-go. So yeah,
Yeah.
it's a bit more informative as a tool than just, discussing ideas.
Oh
Getting
yeah.
hands-on is a different method of doing this whole thing.
I definitely agree with you. You can go like infinitely meta levels. Like, what is their development environment, or how are they addressing my questions,
Yeah, yeah.
or you can go into psychology, you can go into philosophy. So I would say in that regard, if we agree to this, then mentorship sessions can last infinitely. But I would say the core concept here is both parties need to have the feeling of, I'm getting something out of this,
Yeah,
and I'm
exactly.
giving something out as well. Because if this is not there, then I don't think any much further progress can be made.
Cool. I was gonna say let's get into code, but we're already into code. So okay. In one of the podcast notes we had, you had mentioned like FP and OOP as this like, common and practical or popular ideas about how we're trying to think about programming and how we're trying to abstract programming concepts. So, according to yourself, which one is better? I know it's a controversial question. I get that. You don't have to answer it or,
Before I answer, do I get to ask you the same question?
absolutely.
Okay, perfect. I would say both of them are equally right and wrong. I know this sounds highly philosophical, but the reason for that, and this goes back to the previous discussions we had, is try to build. First, as you grow as an engineer, try to make a Frankenstein of yourself. So try to get as many possible perspectives and try to understand the trade-offs, the wins and the losses of each of those perspectives.
Mm-hmm.
So, and I can give concrete examples about that. For example, in object-oriented programming, it's very common that we run into this inheritance hell, or they call it the callback hell in the JS world, where the inheritance
Similar, yeah.
yeah, but it's a similar idea where the inheritance chain is so big, every experienced programmer gets lost into it. And so composition or dependency injection or whatever can sort of remedy some parts of that, but not all of the parts. And
Yeah,
then
sure.
on the other hand, if you have like too many composed functions with one another, like f of j, f of g, of h, of x, then it's very hard to debug this, and it's very hard to understand like what's really going on here. But both of them are equally right and wrong. I would say just try to learn both concepts first and be aware of the trade-offs, the advantages and disadvantages of each of the world, and try to make the best synthesis out of it. So when I write my code on a daily basis, my code is a Frankenstein. In some cases, I use, I mostly write PHP. In some cases, I use object-oriented approach. In some other case, I use functional approach. Do I use a functional PHP has these concepts of functions that are like a map, filter, reduce. Do I use those, or do I use a for each loop? It certainly depends on the context. I would never say something along the lines of always use for each or always use array filter or array map. And this goes beyond PHP. JavaScript has the same concepts of array.map, array.reduce, and for loops. And the one thing I really like about these multi-paradigm languages is that they don't limit you to think in a specific way. I've done quite a bit of Haskell as well, and Haskell is limiting if you ask me. It's a very powerful language, but it's limiting in the sense you need to think in this way.
Yeah, it's opinionated about how the person that uses it's supposed to think.
Exactly. And I think, I saw this is, and this is, I think it's natural why multi-paradigm languages like Python, JavaScript, PHP are holding the sort of the world right today as it is. It's because they give you so many tools and you can think in so many different directions.
Yeah.
And I would say both, to go back to my original answer, both OOP and FP are right and wrong depending on how we use them. when we use them, and with who do we use those. So if I'm working in this very cool startup that is so hyped about Haskell, but I don't know about Haskell, they just want to write um, all of these functional components, I would use something like Lodash or underscore or whatever, and just uh, embed myself into the culture. Or if I were in this culture where everything needs to be an object, Laravel and the alike, it's very hard if you today go and say something like you want to make a pull request against Laravel and say something like, here is this which will make Laravel better, but it goes against Laravel's original ideas, which is everything is an object and design principles. So this is why I think my answers should be both equally right and wrong.
Cool. Well, mine is okay. Well, I'm a functional pragmatist. I consider myself. I'm not really into the whole purity by all means thing. I don't think that object-oriented programming is wrong by any stretch. I used to think that I was more radical, like a couple of years.
All
ago.
of us were. At some point.
I suppose it comes with age. Like wisdom and whatever. I don't think that object-oriented programming is wrong, but I'm sort of wired to think functionally. And I like, because most of my coding time is spent with TypeScript nowadays, I feel like doing functions and doing like what Douglas Crockford told us that was the right way of writing JavaScript. Like it was, I don't know, 12-ish years ago, whatever. Like forget that this exists and like forget that, what was it called? The prototypes exist and whatever. You can do pretty much everything by using objects and like passing stuff along functions. I subscribe to that idea because to me personally, it's easier to think that in that way. But I've done classes. I've done horrible things with classes in the past. I've also done horrible things with functions. But it's again, spoken like a true senior engineer. It depends.
It depends for sure. And if we want to expose our biases now, like what you did, I would also say that I'm more leaning towards the functional world, and mostly because things of I am aware of its disadvantages, but things like side effects, for example. Like in the world of OOP, all you care about objects and inheritance, but side effects. I learned about side effects when I started diving into the FP world. So
no, but side effects are a different abstract idea. Like side effects don't really exist as such in the classical object-oriented sense. When we were learning about classes and the classical academic workout, like a dog is an extended class of animal or whatever.
Yes.
Like we never learned about side effects and concepts like that. So,
right. Yeah. And I agree that there is a certain degree of or blame to academy as well here. But the thing is, if you become aware about side effects, which comes as a concept from FP world, now you can also embed it into the OOP world.
Absolutely, yeah.
In the sense that, so let's say you are constructing your abstractions in such a way, you have a class that does DB updates, and then you have another class which does the business logic. And if you are aware of this side effects concept, you can sort of do ideas like, okay, now my business logic class will be completely pure, and we know the benefits of pureness. And there is this dirty class which will do the DB work. And this dirty class will be really dirty because it can fail. But this logic class which does like bunch of mathematical operations, plus, minus, concatenating lists, whatever it is. So this concept of side effects gives a new tool in the box for the OOP programmer. That is, you can still construct classes like you enjoy doing, but you can limit your classes in a specific way. You can have pure and impure classes. So this is the type of synthesis that I really like, and it made me better as a programmer, I feel, as well, is I can construct my classes in such a way that I know which class can really fail, and I know which class can not fail so often.
What would be a reverse example? What would a functional programming learn from an object-oriented approach?
Oh, okay. So going into the other world, I guess first, objects are important.
Okay.
because they allow us to contain a bunch of properties in a single type.
Yeah.
So, for example, Haskell has the concept of instance, which is different from the concept of instance in OOP, but it really allows you to specify a set of attributes that a specific object has. So, I don't want to get like too deep into mumbo jumbo discussions, but the idea with instances is they further allow you to define type classes, and they allow you to define properties upon types.
Yeah.
And I would not specifically say 100% this came from the OOP world, but if we agree that OOP is about objects and FP is about functions, then you can I would say it's a good agreement to say that Haskell has this concept of objects or type classes borrowed from the object world. And this is stretching the argument. I know that there is a lot of research done around Haskell, and I'm sure I'm wrong about this, but I think if we agree upon certain definitions of what OOP and FP means, we can get to an answer. Because you can also argue the other way around. Well, is it really that OOP programmers learned how to design pure classes by FP, or was there another thing? So it really I don't know that I have the accurate historical representation.
I mean, there's like this interesting misinterpreted abstraction when you've gotten into OOP about what OOP means. It was Alan Kay that originally coined the idea, but he had a very, very different idea imagined, opposed to what we today think of when we think about object-oriented programming. So there's no like right or wrong way to doing this. Maybe it's all about the interpretation of an idea ultimately, and what we could learn from different takes about those interpretations, and maybe adapt and learn something new perhaps.
Yeah, adapt and evolve. I would agree. I have not had the chance to work closer with Smalltalk, but I definitely agree with you. I have seen that the concept of OOP in Smalltalk is very different from the concept of OOP in Java and whatever language.
It's like essentially the event emitter thing, a bunch of objects that exchange messages. Like it's not really like what we know in C++ as a class inherits from a class,
Right.
whatever. It's a completely different take of an abstract idea that somebody described in a paper.
Yeah, and I would also say that both definitions are right and both are wrong at the same time, just using the same argument from before.
Alan Kay would disagree, but never mind.
Alan Kay would definitely disagree, but he were able to climb the abstraction ladder and say, okay, Boro and Darko, with you I will agree that this is the level of OOP we talk about. Then we can sort of have a mutual understanding.
Mm-hmm.
But if Alan Kay is strictly convinced that OOP is Smalltalk, then in this case, what you and I can do is just agree that OOP is Smalltalk and move along.
I'm not sure about Smalltalk, but in one interview he mentioned something that what Node did with event emitters is far closer to his idea of object orientation than C++ ever was. So it's, it's a hot take, a controversial thing, but,
yeah.
There was this other take, I don't remember whose proverb this was. There are like languages that everybody complains about, and there are languages that nobody uses.
Right.
So there's like two sides to this coin. You can go for like the purity of an idea, or you can go with, hey, we have this tool, it works, it might not be perfect, but we can use it. So
yeah, but I just want to reemphasize the point we talked in the beginning, which is abstractions are really just a means or a form of communication.
Yeah.
And the more people become aware of this definition of abstraction, the more you and I, or the more others can understand with each other. And it's the same with event emitter. So, okay, if you and I talk about OOP in the context of event emitter, now I have a better idea and we can build on top of that.
Mm-hmm, sure.
But the other approach is we can disagree on what OOP means and just like, no OOP is Java, no OOP is event emitter. And, but it's abstract. It's abstract enough that only with agreement upon a specific definition will we be able to make particular progress. And now, if you and I want to drive the discussion forward, we can short build upon that. So okay, let's agree it's event emitter. Now how does that relate to OOP in the Java world? And we can have, I know that it's a misnomer, the term is highly abused, but it's a good thing that it's abused, because it can give us more ideas to talk about.
Yeah,
like
absolutely.
A good question here would be, how does the concept of OOP in the sense of Alan Kay, what he originally intended to mean, and in the sense of event emitter in JS, how does that link to OOP in the sense of Java and inheritance and things like that, and abstract classes and whatnot, and function, operation overload and whatever the classes allow you to do. So it still provides a way to communicate further and explore these mazes, where I would say infinite mazes, where they can just give you more and more
Infinite
ideas.
mazes is right.
And the synthesis is the most important part, in my opinion.
Cool. Yeah, and I do agree with that take. Well, that said, do we want to drill further into this, or do we have a closer now?
I would say, how do you drill into the abstraction in the first place? But I just asked this question rhetorically. I think we can go on and on and on.
Yeah, it's probably never going to end, this one, I would say. Yeah.
It's so abstract, and it gives you means to keep communicating and keep drilling and keep learning. And I see abstractions as really important and interesting tool to learn about concepts, but learn from each other as well.
Mm-hmm.
Very powerful communication tool. And like I said, we can keep drilling indefinitely, but I think this is a good place to stop.
A good takeaway for myself would be like what you said, but with an addendum to that. You should adapt your level of abstraction with the person or the group you're trying to talk to and to teach. Especially in our line of work, I feel like it's really important, because a large part of what we do amounts to, teaching and educational work.
Exactly.
Much. So, use abstractions, use them wisely, but adapt to the audience you're trying to talk to.
Right.
So cool. Yeah. Just as I asked you last time, what are you currently reading? Is there anything interesting you're...
I'm still reading psychology, a lot of psychology actually, and it's questions like, okay, so you're dealing with a person, and then let's assume for the sake of argument, this person wants to use mumbo jumbo words, mathematical structures, whatever, and now you get into the psychological realm of programmers. Like, why are they doing this? Is it them, they're trying to prove something to you, or are they trying to prove their self-worth and things like that? So I think understanding others is really crucial to understand yourself first. But also, if you understand others, it will only give you ideas of how you can continue communicating.
Yes.
My whole purpose here is to just keep communicating, because I found the best tool to learn and to just keep learning and growing. And if I ever meet a person like that, I just try to understand more about the psychological aspects, which is another abstraction. So I'm just taking away the abstraction of programming concepts and introducing the abstraction of thinking psychologically about people and why they act in certain ways. And beyond programmers and coworkers, it also helps with your everyday life, because it's all about interpersonal relationships. And when I teach my children, for example, prepare them for tests in mathematics or physics or whatever, I try to be aware of their behavior. Are they nervous? Are they, do they want to do this, or am I forcing them to do that? And this gives you a certain amount of information. Is this really for them? Is mathematics really for them? Or am I just imposing this sort of expectation from myself upon them? You need to be really good at mathematics for you to succeed in life. I think there is a certain degree of truth to that, but I won't digress there. But yeah, lately mostly reading psychological books and taking psychological courses. Coursera, EDX have a lot of content. I would not pinpoint a specific book or course. I just take a large amount of them and try to take the biggest learning points from all of them, and there is a lot to be learned there. And I don't intend on becoming a psychologist in either case. I want to become a better programmer, and I want to become a better teacher or mentor. And the only way to do that is to really understand the other party and understand yourself as well, and find a way to connect these two bridges and go beyond from here.
Yeah, that sounds cool. I mean, that might even be an interesting topic to discuss. How do you become a better teacher, a better mentor, and so forth? We'll probably do an episode about that. I'm still on my startup binge, like micro startups and indie hackers and all that. It fascinates me because, like, it's the kind of people that manages to, create an entire business from essentially nothing, an idea and maybe a business need. And I'm trying to understand what drives those people, and like what are some commonalities between like the indie hackers, content creators, and so forth, because I feel like there's a similar drive between all of them, and I'm trying to find some commonalities there, and just sort of for my own personal curiosity and so forth. And I highly recommend that book. It's just called Make, from this Peter Levels guy on Twitter. He's like a pretty successful indie hacker. His book is like interesting. I would say it's somewhat controversial, not in the traditional sense, but the first thing he's mentioning is like, it's, this book will probably lose its worth the moment it gets published, which is like crazy. He's like, brutally honest and all of that, but it's still an interesting read, and I would highly recommend it. Like, it's really cool if you're interested in that sort of thing.
Well, I think this sort of determines our next episode. You gave a really good sneak peek, and you and I also had this discussion on what it is that drives us. I would only mention one spoiler here, I think, which is with both you and I agreed upon, is genuine curiosity. Yeah. But I would not spoil beyond that, and I think it's a really interesting topic to dive into.
Yeah, cool. So that's been Abstractions for today. This was Boro, I am Darko, and thank you for joining us. See you next time.
Thank you.